Welcome to Data Society's Introduction to R and Visualization course. In this course, we'll teach you what data science is and how to get started with one of the most powerful weapons of a data scientist, R. My name is Dr. Harlan Harris. I'll be the instructor for this course. I have an academic background in computer science, machine learning, and cognitive science. I co-founded Data Science DC and Data Community DC, which are professional groups for data scientists and others in the DC area. I wrote a short book that you can download for free about data scientists called Analyzing the Analyzers, published by O'Reilly. And I currently work in the education sector, building large-scale predictive analytics systems. This course will first answer the question, what is data science? We'll go over how it is used in the world today, what tools you have available, and what types of jobs are out there. Then we'll teach you how to use R, which is one of the most powerful tools available to a data scientist. Finally, we'll teach you how to create compelling visualizations in R, including 2D and 3D charts, and how to overlay spatial data on top of Google Maps. Before we get started, let's set expectations for this course. Data science takes a lot of practice and dedication, and it requires work to become competent and to be able to use tools such as R fluently. The first step, however, is to take this course, so congratulations, you can check that item off the list. Then practice. And when we say practice, we mean to type out the code that we provide and play around with it on your own. Perhaps apply these techniques to data that you know and care about. And when you come across an error where something doesn't work the way that you expect it to, figure out how to fix it. And this is really the best way to ensure that you understand what you're building and what's going on behind the scenes. Along those lines, to get the most out of this class, make sure that you review the class material on your own and practice some more. Complete the exercises outside of class. Practice again. It's also really important to stay current with the latest industry trends and technology developments, as this can help you hone your skills and stay involved in the community. Here's a more detailed outline for this course. As we transition to different topics, you'll see this slide periodically to prepare you for what comes next. So let's dive in. What is data science? So what's going on with data today? Here are a few relevant quotes about the prevalence of data. It's important to keep in mind that data by itself does very little. Just because we have a lot of it doesn't mean that we're being effective or efficient. It's as though you have money under your mattress. It really only becomes useful when you start to use it to buy things or invest in the future. And in our courses, you'll learn how to take that data and invest it so that you'll get good returns. Here are some examples of how companies and individuals are using data today. Data science is relevant in every industry, and its uses are expanding daily. The more people become data literate, the more breakthroughs and applications you'll see over time. Here are a few more real-world applications. From marketing and healthcare to finance and politics, data science is used to answer complex questions. Experts in all of these fields are trying to predict and guide the future. How will people behave? What will they do? What will cause a disease or an outbreak? And what are the forces that determine the pricing of housing and other items? What will happen to the economy? What makes data science so fascinating is how its applications can uncover the hidden relationships about the world, how it can predict people's behavior and lead to better decision making. Data science goes hand in hand with big data. But what is big data? Big data is large amounts of information about moving and storing and manipulating and accessing very large amounts of data, and in particular, the eclectic, novel, fine-grained data often generated by individual people. The term has become synonymous with data analysis, but it's not. Having a lot of data is not helpful without analysis or insights, and that's why you're in this course. This diagram is a variant of one originally created by Drew Conway about 5 years ago, and it's still highly relevant. Data scientist is at the intersection of three domains. First, we have industry knowledge. In order to understand the problem or issue that you're tackling, you should have a good idea of what the limitations are, what resources you have at your disposal, and what you're trying to solve for. Second on this list is math and statistics. While you don't have to be a card-carrying mathematician to be successful, you do need to understand how we can quantitatively define relationships and categories in order to determine how they interact. and you have to understand how randomness works and how to think about imprecision. Last but not least, we have programming. Once you figure out what problem you want to solve and how you want to approach it, you need to be able to tell the computer what to do. So who is a data scientist? A data scientist can have many responsibilities. They may be asked to pose the right questions about data that has been gathered, or to format the data correctly and analyze the data to provide conclusions about the data and what generated it. In many cases, data scientists build data products, which are applications that provide predictions or recommendations or insights back to people who can make the best use of them. And while everything on this slide can come under the purview of a data scientist, they might not all be used for a particular task. It's important to recognize that not everyone who works with data is a data scientist. There are actually several different levels and types of jobs that are available in this domain. And a first level might be that of a data analyst, more likely to be responsible for cleaning, managing the data, creating basic visualizations for others to analyze. Historically, a lot of work like this has been done by business analysts using spreadsheets. But using the tools of a data scientist, you can be much more productive, and you can generate even more compelling work at this level. Next, we have a data modeler who will build basic statistical models to answer specific questions. While they often have a very good understanding of the data, they're not expected to know the tools as broadly as a data scientist, and they're more likely to be using off-the-shelf software to do analyses. A lot of traditional statisticians fall into this category. But the new role of data scientists has a command of a broader range of tools and methods, including computer programming and the technologies used in the big data world. They're able to ask the right questions to guide research, and they do so while thinking scientifically about how the world works. This chart illustrates how companies work with varying levels of data and what skills they might look for in employees. Different organizations are more or less mature in how they use data, and different sets of skills are required to make a big impact. The first column here outlines a company that is not so data-driven, but does work with some data using tools such as spreadsheets, typically generating insights with bar charts and other related types of visualizations. This company would require fundamental skills with basic tools, but might not require much knowledge in software engineering or data processing, as would a business that is starting to move towards data collection in the second column. Organizations that produce data, such as Twitter or NASDAQ or a government agency, would be looking for data skills across a broad spectrum. A critically important role is at organizations that have matured to the point where they use advanced analytical methods to make decisions and to drive the bottom line for their organization. And so keep all of this in mind as you're progressing through this course. What type of work do you want to be doing? How do you want to fit in? And what sort of impact do you want to be able to make? Almost every large company these days hires data scientists and others with similar skills, as do many smaller organizations. Here are just a few companies that hire data scientists, but there are many, many more out there, and they span just about every industry. Oftentimes, you can actually make the most impact by helping an old company in an old industry move beyond the basics and how they think about and work with data. You don't have to work with petabytes of data at a Silicon Valley startup. That's an option, but there are lots of ways to make a big impact. You might be wondering how much data scientists make and why it's worth it to become more proficient with data. The skills with software and statistics that are key to being a data scientist are incredibly valuable for almost anyone in today's economy. According to a recent survey, data scientists can earn a median salary that can be up to 40% higher than predictive analytics professionals, which are roughly the data modelers that I mentioned previously, at the same level of seniority. So even if you don't want to invest the time to become a full-fledged data scientist, having some of their skills and understanding what's possible can be incredibly valuable in whatever job market or career path you pursue.